On lesson 9, we're going to do some reviewing of scale drawings again. So the review question says, suppose you're making a scale drawing of the following rooms shown in the table below. Find the length of each room on the scale drawing with the given scale. And then it says find the scale factor. So we're just going to start with the first question. We need to find the length of each room on the scale on the scale drawing with the given scale. So if we just start with the library, so right here it says start with the library, we're going to look and to figure out what's going to go in our if spot. Well, we have two numbers. If you look at the library, we have its actual length is 24 feet and the scale is 1 foot is to 6 feet. So we should know that in the if blank we always put our ratio. So right there is our ratio or our scale. So we're going to write 1 foot is 6 feet. And so the labels over here match, but there is a kind of an issue when we have the same labels because they don't really help us know where to put the numbers because they are the same. So if we remember what scale measures the model compared to the real. So I'm going to write just the model on top and the real on the bottom to help me out. Okay, if I look at the library, the other number says the actual length is 24 feet. The actual length would be the same as the real, so that's going to go right here on the bottom. And the question's asking me, find the length of the room on the scale drawing. Scale drawing is your model, so that's where your X goes. To calculate it, it's quite simple now. You're just going to multiply diagonally. 24 times 1 is 24, and then divide by 6, so your answer is 4. So the length of the scale drawing is 4 feet. And to do the scale factor is we just start with the scale, and remember the scale was 1 foot is to 6 feet. Scale factor, the only thing you have to be worried about is the labels have to be the same. They are, so that's easy. And basically it's the top divided by the bottom, and that's already a reduced fraction, so we just say scale factor is 1/6. It means that the model is 1/6 the size of the real. We're just going to skip the next question on the back, which says the school gym. So we skip that in class. We're going to go to the question that talks about King Kong. Apologize about your copy. I know it's very dim, but I can write the numbers that you need here. It says for the movie King Kong, the special effects crew is creating a larger model of the gorilla named King Kong using the smaller scale model shown below. If they used a scale of 16 feet in the large model, representing 1 foot in the small model, what's the height of the larger model? I think this question is difficult just because we're so used to scale being model to real, and I feel like when you read this question, we're looking at one model comparing it to another model. So what we're going to do to get through this question is we're just going to rely on the labels. So when in the question, if you look, it's talking about 16 feet in the large model represents 1 foot in the smaller. So you should be able to notice there that that's your comparison. That is going to go in your if spot. So you're going to go 16 feet, but we're going to be more descriptive than just feet. 16 feet in the larger model represents 1 foot in the smaller, so I'm going to put an S there for smaller. The reason I'm being really picky on that is because when I have feet on both top and bottom, that doesn't help me know where the other number goes. But if I know the top is talking about the larger model and the bottom is talking about the smaller model, that makes it much easier. And the question says, what's the height of the larger? I don't know the larger, so the X therefore is by the L. And if we look in the question, how big is the smaller model? Up here, it doesn't tell us. It never tells us how big the smaller model is. We have to look at the picture. And there's actually a picture of King Kong right here. Okay? And right here is where it says the smaller model size. So it's 2. To calculate that now, you're just going to multiply across. 16 times 2 is 32. Divide by 1. The answer is it's going to be 32. The next question says Washington Middle School students want to make postcards of their mosaic mural as an art project. The mural is 15 feet by 15 feet. And again, I apologize for this picture. So here's this mural, and this is on the sidewall of their school. And if you look at the picture, you can't see it, so I'm going to write it in. It says it's 15 feet by 15 feet. So there's basically a picture of their school with a mural on it. It says the scale, they want to use a scale of 1 inch to 3 feet was used. What's the height of the postcard? And then another question is what's the scale factor that indicates how much smaller the postcard is than the mural? So we're going to start with the first question. What would be the height of the postcard? So in the question, you can see that they use a scale of 1 inch is to 3 feet. So that's going to go in my if spot. 1 inch, 3 feet. This makes it easy because I know my labels over here then are inches and feet. And I don't know the height of the postcard. The height of the postcard is your model, so that's my top number. But I do know how many feet wide the postcard is, the mural, and it's 15. And if I multiply across, multiply diagonally, 15 times 1 is 15, divide by 3 is 5. So basically, my postcard is going to be 5 inches. Tall, sorry. And then the next question is, what's the scale factor that indicates how much smaller the postcard is than the mural? Scale factor is very different than scale. It does start with a scale. So on this question, the scale was 1 inch to 3 feet. But the important thing we need to know about scale factor is we can't do a scale factor unless the units are the same. So I have inches and feet. I have to have them the same unit. I'm going to have to change this bottom number to inches. So 3 feet, there's 12 inches in a foot. So 3 times 12 is 36. Now I have the units the same. So now I have my scale factor. Scale factor is 1/36, which is basically telling you that the postcard is 1/36 the size of the mural. All right, this question came out much clearer. It says, Tammy looks at a map, finds the Atlantic City beach is 2 3/4 inch from the hotel where she is staying. The scale on the map is 1 inch is 500 feet. How many feet away is the beach from the hotel? This is a very classic MCA question. I want to figure out what they are giving me, and then they're giving me a scale, and I should know that scale is always your comparison. So that's going to go in my if blank. So 1 inch is 500 feet. And so the label over here is going to be inches, and the label over here is going to be feet. The question is how many feet? I don't know the feet. That's going to be where my X goes. I'm looking for the other number that talks about inches, and up here it says it's 2 3/4 inches, but I'm using a calculator, and 2 3/4 is real hard to punch in a calculator, so I know it's 2 whole. 3/4 is 3/4, so that's the same as 0.75. All right, and then to solve, you're just going to take your multiple numbers diagonally. 500 times 2.75 and divide by 1. And the answer is 1,375. All right, the next question says, Tariq's model of a truck is 9 inches long, and the scale used for creating the model is 0.5 inches is to 3 feet. He determined the actual truck should be 27 feet long. Is he correct? And explain. Basically, we just have to figure out if he did the right math or not. So I'm going to start out by finding my ratio statement. Right there it is. My scale is 0.5 inches is 3 feet. So that's where you would write in your if spot. So then right here is going to be inches, and right here is going to be feet. And the top sentence says the model truck is 9 inches. So that's going to go up in the top blank. And the bottom, we could either figure out how many feet it should be, so we could put an X there if you wanted to, and then figure out is it 27 or not, or we could put his number in as 27. And the question is, are these true? Is this a true statement what I wrote? Basically, is this equal to that? Many ways you could do that. You could multiply these diagonally. If you multiply them diagonally, these should be the same number. You could cover this number 27 up and multiply across and divide and see if you get 27. You could look at the bottom and go, my bottom's getting 9 times bigger. So my top, is that getting 9 times bigger? And the answer is no. No matter which way you check it, they are not the same. So therefore, he is wrong. It is not. This number should not be 27. All right, the next one's a challenge problem, although I'm not quite sure why it's challenged because it doesn't seem that difficult. It does say the scale on a map of the Twin Cities is 3 centimeters to 2 miles. The distance between Minneapolis and St. Paul is 9.2 miles. How far apart on the map in centimeters is the cities? So I'm just going to go ahead and I'm going to start and go, well, there's my ratio. 3 centimeters is to 2 miles. That's my scale. So the top number will be 3 centimeters. The bottom number will be 2 miles. Okay? And then obviously the labels are going to be the same on the other side. And the other number they give us is 9.2 miles. So obviously that would go in your miles blank. And the question's saying, how far in centimeters? We don't know that number. Okay, to calculate this, you need to multiply the diagonal numbers, which would be 9.2 times 3. Then you need to divide by 2. So your answer, 13.8. All right, the last question on the packet we did not do in class together, so you can also skip that.